We're going to continue to dive into this chain rule idea and concept today. We've looked at some basic chain rules and some additions, some sums, maybe differences, an easy quotient rule. Today we're going to look at the product rule along with the chain rule, that we have to do both of them within the same function, or define the derivative within the function of the function. So f prime of x. What I'd like for you to notice with this problem, we have 2x plus 1 squared, and we're multiplying it to x minus 3 to the third. So we have two things being multiplied together. That's where our product comes in. So we're really multiplying two things together first. Within each of those items or terms, we're squaring or cubing, so we're taking them to an exponent. That's where our chain rule comes in. So how do we find the derivative? We're going to use the product rule first because we have two things being multiplied together ultimately. So what's our product rule tell us? The product rule tells us the first, or 1, derivative of the second. So derivative of x minus 3 to the third. That gives us, we're going to bring the 3 to the front, x minus 1, or x minus 3, sorry, to the second. That stays the same, decrease the x by 1, times the derivative of the inside. To that, we're going to add the second, x minus 3 to the third, and then derivative of 2x plus 1 squared. I'm running out of room. I should have started over at the side, shouldn't I? Oh, well. We're going to bring our 2x plus 1 to the first, and then we're going to multiply by the derivative inside, which is 2. There we go. All right, so what's that now going to look like? I promise the next one I'm going to start way over on the left side. So what can we do to clean this up? Right now we have 3 times 1. That gives us 3. And then our 2x plus 1 to the second. And then our x minus 3 to the second. So that we are going to add, we have 2 times 2. Our monomials, or our constants. We have 4. We have our x minus 3 to the third. And 2x plus 1 to the first. That was 2x plus 1 to the first, wasn't it? All right. So this looks like what we did way back when we simplified our rational expressions, our rational functions. I threw a couple of these in for you as well. So what I'm going to ask you to do with this, I'm going to ask you to find common factors to be able to clean this up slightly. So we have 2x plus 1 squared, and we have a 2x plus 1 to the first. We have two of the terms that are the same. Or this term is in common with both of the terms that we started with. We take out the smallest exponent, 2x plus 1 to the first. If you want to put that 1, you can. We have x minus 3 in common, and we have two of them. Again, we're taking out the smallest exponent of x minus 3. So we have x minus 3 to the second. Then we're bringing our brackets, and we're going to take in what's left over. So basically, we're going to take these two terms out of both of these two terms. This is our GCF, if you recall. So we have our 3. We had 2x plus 1 squared. We're taking one of them out. So we'll be left with 1 in our brackets. X minus 3 to the second. We're taking both of those out. So we won't have any x minus 3's in our first term in our bracket there. But in our second bracket, we can pull out, we have our 4 left over. X minus 3 to the third. We're taking two of those out. So we have x minus 3 to the first left. And then 2x plus 1 to the first is going out as well. We can go ahead and clean up those brackets to get a nice clean answer. So we get 2x plus 1, x minus 3 to the second. In here we have 3 times 2x is 6x, and a 4x. We're adding those together, so we get 10x. We have 3 and then a negative 12. So 3 times 1 gives us a 3. 4 times negative 3 gives us negative 12. 3 minus 12 gives us negative 9. And that gives us our nice, clean, beautiful answer. Don't you love the product rule with a chain rule? If you want, you could multiply the 3 through and write that above it, 6x plus 3. Some of us kind of need that extra little bit of seeing visual, which is not a problem. That way you can see your 10x minus 9 maybe a little easier. Example 2, we're not going to deviate a whole lot from that one. I think this is enough work for the day, isn't it? So, our derivative, we're going to multiply these two together. We're going to multiply them. So our chain rule, we're going to rewrite the first, x squared minus 4 to the second. We're taking the derivative of 2x plus 1 to the fourth. Bring our exponent to the front. Inside stays the same. Decrease the exponent by 1. Derivative of the inside. Remember, don't forget that derivative of the inside. To that, we're going to add the 2x plus 1 to the fourth. And then derivative of x squared minus 4 to the second. Derivative of the first. Bring the 2 to the front. The inside stays the same. X squared minus 4. Decrease the exponent by 1, so that goes to 1. And then derivative of the inside gives us our 2x. Again, we can go ahead and clean this up a little bit. We multiply the 4 and the 2, gives us an 8. X squared minus 4 squared. And 2x plus 1 to the third. To that we're adding, we have 2 and 2x gives us 4x. And 2x plus 1 to the fourth, and x squared minus 4 to the first. I'm going to ask you to go ahead and factor out our GCF. So 8 and 4x, our monomials there, we can factor out a 4. In our binomials, we have x squared minus 4 squared and x squared minus 4. So we get x squared minus 4. We can take out a 1, or one of them. 2x plus 1 to the third and 2x plus 1 to the fourth. Again, we can take out the smallest exponent, so we can take out 3 of those. 8 divided by 4 gives us 2. X squared minus 4 squared. Taking out x squared minus 1 to the first, subtract those exponents, we get x squared minus 4. And then 2x plus 1 to the thirds are going to cancel each other out. We've factored out all of them. 4x, factoring out a 4, we're left with an x. 2x plus 1 to the fourth, we're taking 3 of those out. So we're left with 2x plus 1 to the first, and x squared minus 4 to the first is being left. Finally, and you say, yay, finally. Oh my goodness. At what point do we call it a day? We're getting close there, aren't we? Multiply the 2 through, we get 2x squared minus 8. Multiply the x through, we get 2x squared plus x. Add in like terms, we have 4x squared plus x minus 8. And that's going to be our nice, clean answer. And you say, how clean is that answer? Well, that's as clean as we're going to get. A couple of more problems. Here we're going to have a monomial times a binomial to a power. But I want you to see that we again have a product rule. We have x squared and multiplying it to x minus 5 to the sixth. Starting way over here on the left, we're going to rewrite the first. So 1, d2, x minus 5 to the sixth. We have 6, x minus 5 to the fifth, decreasing the exponent by 1, times 1. To that, we're going to add the x minus 5 to the sixth, and then derivative of x squared is 2x. Cleaning this up, 6 times our 1 times our x squared, our monomials, we get 6x squared times x minus 5 to the fifth. To that, we're going to add a 2x times x minus 5 to the sixth. Can't really do a whole lot with that. Write the monomial first, and then the binomial, we normally like to write our functions as monomials, then binomials, then trinomials, and so on and so forth. Just looks a little more aesthetically pleasing, I guess, is the reason that we do it. Go ahead and factor our GCF. GCF for the monomials there, our 6x squared and our 2x is 2x. And then x minus 5 to the fifth. Our big old brackets, 6x squared, we're taking out a 2x, dividing it by 2x, gives us 3x. X minus 5 to the fifth are gone. Here our 2x is being factored out, and we have an x minus 5 left. One last time to clean it up. We clean up those brackets. 3x plus x gives us 4x minus 5, and we got a nice clean answer. Don't we like the monomial time a binomial a little better than when two functions are binomials? I do. All right, f prime. Last example. Again, we have 3x squared, and we're multiplying that by x to the third plus 9 to the fourth. So we rewrite our first, 3x squared. Derivative of the second part, we have 4. We have our x to the third plus 9 to the third times derivative of the inside, which is 3x squared. To that, we're going to add our second part, x to the third plus 9 to the fourth, and derivative of 3x squared gives us 6x. And that's going to go ahead and give us our answer. We can clean this up. Or that's going to give us our derivative. cleaning this up, we have 3x squared, we have 4, and another 3x squared. So that gives us 9, and 4 gives us 36x to the fourth, and then x to the third plus 9 to the third. So again, we're not going to do a whole lot with that last part. Put our monomial first, and then our binomials to make it pleasing to the eye. All right, so 36x to the fourth and 6x, we can factor out a 6x. That's our GCF. And then x to the third plus 9 to the third. Again, we're going to take out the smallest exponent when we factor out for our GCF with a quantity. 36x to the fourth, we're factoring out that 6x, so we're going to be left with a 6x to the third. X to the third plus 9's go away, plus our 6x is going to go out, and x to the third plus 9. So our nice, clean, beautiful answer. Yes, I think it's beautiful. I know you may not, but that's a 7. So we have 7x to the third plus 9 as our final answer. So that's an idea and examples of where we see the chain rule with the product rule. And yes, I know you're asking yourself, is there a chain rule with the quotient rule? Of course there is. Just wait a day. Good luck.